Okay, video number 5 in the unit. I'm just going to talk about lines of symmetry, rotational symmetry, point symmetry. Okay, line of symmetry, pretty easy. If you could draw a line that would cut a shape equally in half so that when you fold the shape, it lines up perfectly with itself on the other side, then you have a line of symmetry. A rotational symmetry is if you can turn a shape, okay, any amount of degrees, 180 or less, and it lines back up with itself. Point symmetry is if you turn a shape 180 degrees, so you pretty much flip it, or not flip it, but you rotate it all the way around to the other side, 180 degrees, and it lines up perfectly with itself. Okay? So if we think about problem 3, identifying lines of symmetry, we got a regular hexagon. So how many lines could we draw through this hexagon that cuts it equally? Okay, so we got obviously this and this way, because if we folded it in half, it would line up perfectly. And we also have through the vertices on the corners. Okay. Now that might look like that's it, but we actually got one more set. So we can go cut those two triangles in half. Okay. So pretty much what I was trying to get you to understand is that for a regular shape, the lines of symmetry, there is the same number as the number of sides, only for a regular shape. So this would be 6. A square would be 4, an equilateral triangle would be 3, a regular pentagon would be 5, so on and so forth. Okay. Now we have to see if this has rotational symmetry. So this is actually easy to show on a smartboard. So if I rotate this shape any amount of degrees, will it line back up? Well, let's see. Nope, 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 nope. That's 180. It's not lining up. All right. It doesn't actually line up till you go all the way back around. So this shape does not have rotational symmetry. Okay. What about this star? Let's see. So let's mark where the point. Actually, let me start over. So mark where the point is so you can watch it spin. Okay. So if we take this and rotate it, we got 1, 2, 3, 4, 5. Okay. So there's actually 5 different ways we can rotate it, and that is what's going to help us find our angle of rotation. So for this one, we got, yes, it has rotational symmetry. A full circle is 360 degrees. There was 5 possible turns we could do. So our angle of rotation is going to be 360 divided by 5, which is 78. Nope. 72. Now you can try that one to see how far you have to rotate it to get it to line up perfectly. I'll show you, and then you guys can figure out the angle of rotation. So that's when it lines back up with itself. About. So just figure out what that angle of rotation is. Okay. I'm just going to go ahead and cover tessellations in this video because it's not really too much to it. Now, a tessellation is a repeating pattern that completely covers a plane without gaps or overlaps or negative space. Okay? So the shapes can't overlap and there can't be any gaps. You can make tessellations with translations, rotations, and reflections. Okay? So this one is asking, what is the thing that's tessellating in this one? Right? What's the thing that's repeating? I'm going to say a cool cat. And what transformations are used? Well, if you go from yellow to pink, right, or if you think about what that is, that's just a translation. But yellow and pink aren't technically the same. So also, what they did to get from yellow to yellow is they would have had to flip it, right, because the ears are now facing, if they were facing down, they're now facing up. They would have to flip it and then slide. So it's also a reflection. Okay. Here's a little thinking exercise. Why does a regular hexagon tessellate but not a regular pentagon? Okay. The idea here is you're going to have to find the measure of one interior angle and it's going to have to be a factor of 360 when you find it. Okay? So if you don't remember the way you find the measure of a single interior angle of a shape, the equation is 180 times n minus 2 divided by n. Okay. Now the rule is going to be when you find this, you're going to have to be able to divide that by, or divide 360 by that number and come out with a whole number. Okay. So kind of think about that. I don't want you to work it out here. I just want you to think about why it would work for a hexagon and not a pentagon. And I'm going to show you on the next one how to use the equation to determine. So in order to not leave any gaps, okay, if a figure is a polygon, the sum of the measures around any vertex must be 360 degrees. Okay. Now, figuring out if a shape tessellates or not, we have a regular, because only regular shapes can tessellate. Has to be all sides are the same. We got 180, 18 minus 2 divided by 18. Okay. That would give us 180 times 16 divided by 18, 160. Now, what has to be true is that you need to be able to divide 360 by the measure of the interior angle and get a whole number. So for this one, 360 divided by 160, you're going to get 2.25. So the answer here is no, it doesn't tessellate. Over here, let's look at this equilateral triangle. We don't say regular triangle, we say equilateral triangle, but it's the same thing. Okay, all the sides are the same. We got 180, 3 minus 2 divided by 3. That's going to be 60. Okay. Now we all know 360 is divisible by 60. You get a whole number, 6. So the answer here is yes. That's pretty much the idea. Once you find the measure of one of the interior angles, you just see if you can divide 360 by that number, and if it's a whole number, the shape will tessellate. Okay. Now, a figure doesn't necessarily have to be a regular polygon to tessellate, but for our purposes, If you see the questions on the test, just think regular shapes tessellate. And that is the end of the unit. That's the last new thing you'll ever have to learn in geometry. So, hope you enjoyed.